So when it comes to optimization problems, or to be more precise, when coming to word problems, it's terribly important that you read the statement carefully and underline the keywords and the key phrases. Then it's necessary for you to make your own sketch so as to visualize the situation. And then you need to come up with mathematical expressions or equations to actually solve the problem. So let's look at this one. So in this case, they say to us we have a wire which is 12 meters long, and this wire is cut into two pieces. So we are given the total length of the wire, which is fine. Now they say one part is bent to form an equilateral triangle, and the other part is bent to form a square. They say a side of the triangle has a length of 2x meters. So the first thing they're asking from you is to write down the length of the square in terms of x. And then secondly, they say, if this square is now used as the base of a rectangular prism with a height of 4x meters, please determine the maximum volume of this rectangular prism. And it's very important to underline the phrase maximum volume as well. Okay, fine. So let's begin so we have read our statement and we have underlined the keywords and the key phrases. So now we need to make our own sketch, right? Well, here we need to make 3 sketches, but it's not really necessary, but it's necessary. So yeah. Now, firstly, we have an equilateral triangle. And one thing we know about it is that all the sides are equal. Let's forget about the angles. The angles are not important in this context. So this side is equal to that, and this one is equal to that as well. Then we move along. We talk about a square. Well, this is how a square is going to look like. And similarly, a square is characterized by the fact that all sides are equal. So now it's time to move along to the rectangular prism, all right? Well, this is roughly how a rectangular prism is going to look like. But remember that it has to have a square base, okay? Yeah, so more or less. I was actually taught how to make this sketch, I think back in grade 6. Right. So of course, a prism is a 3-dimensional figure, right? But the most important thing is the base is a square, right? So which means this is also a square at the top. The top and bottom surfaces are both squares. Well, that's fine. But remember what they said to us. They said the height of this rectangular prism is 4x meters. So these are our very nice sketches. And if we read the statement, we can see that the function that we are working with is the volume function. How do we know that we are working with the volume function and not the area function? Well, it's because the area is not mentioned, but more precisely, it's because we want to maximize the volume, okay? Okay, fine, but we are not there yet. We are still on the first question. So what is the first question asking from us? Well, it's something that is very simple. Tell us, what is the length of one side of a square? That's all they're saying to us, right? So here we need to analyze a little bit, okay? Remember what they said to us. They said the length of each side of a triangle is 2x meters. In other words, We have 2x, 2x, and 2x. In simple language, the length of the wire that is used to form a triangle is 6x meters, right? But now these 6x meters, we also see that it's the total distance around the shape, which we can call the perimeter. So we can simply say the perimeter of the triangle is 6x meters. Are you fine with me? Are you fine with me? Is it a right question to ask? I don't think so. I wanted to say, are you there with me? Forgive me, guys. I'm getting old. Okay, fine. Now, what about the square? Think of it. This is what we had initially, okay? You need to visualize these things. So let's say this is your very nice and beautiful wire, right? And then we decide to cut this wire into two. They didn't say into two equal parts, no. So it means we can cut it at any point, right? So let's say we choose to cut the wire here. And then we say this length is just going to be 6x. It's the one that we use in order to form a triangle. But of course, we understand that the total length of the wire, it's just going to be 12 meters. So the question then is, how much is the length that is remaining in order to form a square? Well, you can see clearly that length is going to be 12 minus 6x. Do you see that? Of course you do. So that is just that. Okay, fine. So what you see here is the total length of the wire that is used to form a square, right? In other words, it's the perimeter of a square. Do you get it? So I think it's necessary for you to tell them that the perimeter of the square, well, please write the square in full. So tell them that the perimeter of the square, it's just going to be the total distance around the shape, all right? But since a square has four sides, which are equal to each other, of course, then it means in order to get the length of each side, we just divide the total length by 4. So that's what we say. We say, okay, fine. The length of a side, it's just going to be 12 minus 6x divided by 4. So that's what you have. And of course, if you separate the fractions, you'll say 12 divided by 4, which is going to give you 3. And 6 divided by 4 is 3 over 2. So you can just say you have 3 over 2x there. And this is the length in its simplest form. And you have your two very nice and beautiful marks. Not all bad, guys. You're now working for 7 marks out of 9. Right. So now we understand that the 3 minus 3 over 2x is now going to be the side of this square, right? Each side of the square. So that's what we have there. But now they're asking us to calculate the maximum volume, given that the square is the base of this prism. And since we understand that the function we are working with is the volume function, then the question is, how do we define the volume of a rectangular prism? Well, it's very easy. The volume of any figure, it's just going to be the area of the base multiplied by the height, all right? So that's what you're going to say. So you'll simply say, well, the volume is going to be what? What is the area of the base? Well, the base is just going to be side multiplied by side, which is side squared. But of course, we understand that each side has a length of this much. So we square this, and then we multiply it by the height. Do you see that? Of course you do. So that is what we have. So now we need to expand this volume. And the nice thing that we see is that our volume is a function of x. So how do you expand this part? Well, you use the FOIL method. So you're just going to write these brackets, or rather repeat the brackets twice, and then you FOIL, of course. So when you say 3 by 3, you get a 9. And when you say 3 by 3 over 2, well, you get 9 over 2x minus 9 over 2x plus 9 over 4x squared, all right? And then you collect your like terms. So you still have your 4x here. The 9 is still there. The denominators are the same, so we subtract the numerators. So we get negative 18 over 2, which of course we understand is negative 9, right? And of course we still have our 9 over 4x squared. So we need to go to the next slide. I just need to quickly take a very nice picture and we should be fine. Right, so this is where we were. We set our volume in terms of x. It's just going to be 4x into 9 minus 9x plus 9 over 4x squared, right? Then we are just going to distribute the 4x. So 4 by 9 is 36x. And of course, here we still have 36x squared. And 4 by 4, well, they cancel out. So we have 9x cubed, right? So after getting our volume function, then it's time to differentiate because the maximum or the minimum occurs at the turning points, at least at your age, right? So this is as we say, okay, fine. Differentiating this according to the power rule, we get 36, 72x, 27x squared, sorry. Do you know how to differentiate? So I don't need to explain how we got the 36, 72, and 27, all right? Then the next step is to equate the derivative to 0. And we actually observe that we have the highest common factor here, which is just going to be what? What is the highest common factor here? Well, the highest common factor is going to be what? What is the highest common factor? Well, the highest common factor is going to be, it's going to be, let's see. So what is 27? Well, 27, we can write it as 9 times 3. Okay, what about 36? We can write it as 9 times 4. Okay, fine. What about 72? Well, 72, we can write it as 9 by 8, all right? Of course we can. Why are we doing this? It's because we want to divide throughout by the highest common factor, which is going to be a 9. Why? Because we want to write our equation in standard form, right? So that it can be easier to factorize, or we can just use the quadratic formula. So we equate our derivative to 0, which is nice. And then we say, well, 9 is the highest common factor. So If we divide throughout by 9, we get 3x squared here, and here we get 8x, and here we get a 4, and this is equal to 0. Then from this point, you can actually proceed in one of two ways. You can either use trial and error in order to factorize this advanced quadratic equation, or you can actually use the quadratic formula, right? So let's just use the quadratic formula. It's easy and straight to the point. But of course, if you like to factorize, it's always nice to know how to factorize. Or maybe I can teach you how to factorize in this case, all right? Yeah, let's do that. So we are just going to go to our nice table. What are we going to say when we get here? Well, easy. We are going to list the factors of the first term as well as the factors of the last term, right? So this is the first term and this is the last term. So the first term, 3x squared, can only be written as 3x times x. Or maybe I can just use a dot to be more mathematical. But 4, we have two possibilities. We can either write it as 4 times 1 or as 2 times 2, right? So now we want to factorize this quadratic equation. So we are looking for a combination of factors such that if we add them or subtract them, we get negative 8x. And by combination, I mean this thing times that. It's one combination. This one times that, right? Yeah, that is a combination. So let's try and see which one is going to work. So if you say 3 by 4, you get a 12. And if you say x by 1, you get x. There is no possibility of us getting 8 if we add or subtract those two. So it's not a good combination. What about if you say 3x by 1 and x by 4? Well, you'll have 3x as well as 4x. So they can't add up to the 8. So it's also not a good combination. So if we go to the last one, we say 3x by 2, we get 6x. X by 2, we get 2x. They're just going to add up to our 8. So we are just going to use those two. But the question is, how do we write them? Well, we have 3x, which is multiplied by 2. And this is going to give us 6x. And then we have x, which is multiplied by 2 as well. And this is going to give us 2x, right? But then since the middle term is negative, it means both of them, they must be negative so that we get negative 8, right? Okay, fine. So you need to know that what you have horizontally is the first vector, and this one is the second vector, right? What about the signs of the vectors? Well, this is the sign of the first vector, and this is the sign of the second vector. So you are now simply going to come and say we have 3x minus 2, x minus 2. And using the zero factor law, you find that x equals 2 over 3 or x equals 2. So in this case, we got two values of x, right? That's fine. But remember, we are looking for the maximum volume, right? So we need to substitute both of these values of x into the volume function and see which one is going to give us the bigger volume. Yeah, so let's just go to the first equation of volume that we came up with. And let's begin by substituting x equals 2 over 3 and see how much we get. So we say 3 minus 3 over 2, open bracket, 2 over 3, and then we square the whole thing, multiplied by 4 into 2 over 3. So we get 32 over 3. Okay, fine, which is fine. And then we move along and substitute x equals 2 at the very same place, right? So when we substitute x equals 2, we actually get 0. So it means we can't choose x equals 2. So then the question is, what are we going to say? Of course, we don't show them, right? We don't show them the step whereby we are substituting our x values into the volume function. No, they don't need to see that. So what we will say here is that therefore, the maximum volume, it's going to be at V of 2 over 3, which is going to give us 32 over 3. But you remember the unit. If you just say 32 over 3, they have every mark, in fact, every right of not awarding you the mark. So, yeah, this is just going to be the maximum volume of your rectangular prism. And you should be happy in this case. So thank you so much, guys, for watching. I really hope it helps a lot and it makes sense. But in the event it doesn't make sense to you, you still need a little bit of clarity. Please don't be shy. You can just comment on the YouTube channel, or better yet, you can just text me on WhatsApp. So it's 071-936-8289. Yeah, it's the official business account number. So yeah, no, thank you so much, guys, for watching. Let's see you in the next video.